Question. A satellite of mass ms revolving in a circular orbit of radius rs around the earth of mass capital M has a total energy capital E. Then its angular momentum will be. Now this is for satellite. Satellite mass is ms and orbiting in a radius of rs around earth of mass capital M has a total energy capital E. So velocity of satellite is given by when it is revolving around earth. Suppose this is earth. The satellite is revolving around earth. So what is its velocity? We want to calculate. Velocity of satellite, Vs of the satellite will take it, is given by the force between the earth and the satellite will provide the necessary centripetal force. What is the force between them? Gravitational force, capital G, capital M, small m, s for the satellite divided by rs square is equal to centripetal force, ms vs square divided by rs. So velocity of the satellite will be under root of g capital M divided by rs. So what will be its kinetic energy? Kinetic energy will be equal to half of ms vs square. So this is half of ms into capital G capital M divided by rs square and under root. So this will be this. And it is given kinetic energy, we got it as equal to half of mgm by rs. Total energy is capital E. So satellite revolving here will have kinetic energy as well as potential energy. So let us calculate potential energy. Potential energy will be equal to minus G capital M small ms divided by rs. It is the amount of work done. This is earth. This is the satellite. In bringing the satellite from infinity and trying to keep it at this position. So the total energy will be equal to, now total energy is given as capital E. It is equal to kinetic energy plus potential energy. So adding minus G capital M small m s divided by 2 rs. This is equal to E. Now we want to calculate angular momentum. The angular momentum capital L is given by what relation? L is equal to mass of the satellite, velocity of satellite into radius of the satellite. So mass of satellite into velocity capital G into capital M by radius of satellite to the power half into radius of satellite. So angular momentum will be equal to capital G capital M m s square into, I can bring this rs also inside it, under root. Now if I take this equation as equation 1, this equation as equation 2, from 1 and 2 we can relate total energy with angular momentum. L is equal to G capital M small ms divided by 2 rs can be written as 2 capital E ms rs square under root, or it can also be written as 2 capital E ms rs square to the power half. This will be the angular momentum of the satellite. So what is the correct options? Let us look into 2 capital E ms rs square to the power half. This is the correct option. 2 capital E ms rs square, wrong option. 2 capital E ms rs to the power half, wrong. rs square it should be. 2 capital E ms rs, this is also wrong option. So correct option will be option A. So what we have done in this problem? First we calculated the velocity of satellite. Once we know the velocity of satellite, we can calculate the kinetic energy. From this we also calculate potential energy. So total energy we got, and that is given as capital E, equation 1. Angular momentum mvr. So since we know the velocity, substituting here, we got the angular momentum. Now this capital G capital M ms by 2 rs we try to substitute in terms of E in this. So L is equal to under root of 2 E ms rs square under root. This is the value of angular momentum.